Thank you for that very kind introduction. I will try to remember it when life is tough. I'm going to speak about fibrous materials naturally occurring in mines, some health effects related to that, and also approaches to prevention. So I'll speak about the fibers. What fibers are we speaking about? The problem, where they occur, how risk identification, risk assessment took place for this type of problem, and also different approaches to risk management. How do we know when there is such exposure? How can exposure be avoided? How can it be reduced and monitored? And what guidelines are available? And finally, something about what can we consider as possibly safe in the meaning acceptable risk levels when it comes to these fibers. So let's start about defining what we are speaking about. The legal definition of asbestos includes one major group of minerals called serpentines, where chrysotile is the most important one, and that's the white asbestos, which has been 95% or something like that of the global asbestos production for commercial use. Then there is the other major group, which is slightly more interesting in this context, which is the amphiboles. And of these, crocidolite and amosite have been mined for commercial purposes, also anthophyllite, especially in Finland, while actinolite and tremolite are mainly contaminants which occur in the mines. These minerals are hydrated silicates with varying metal composition. So they are all silicates, but they vary in the chemical composition. And what's important to know is that when a mineral occurs, which is called rhyolite, it can be both in a fibrous form, which is what we usually call crocidolite, but it can also be in a non-fibrous form. So I have to know for the specific mineral we speak about, the specific chemical composition, if it is in a fibrous form or in a non-fibrous form, because it makes all the difference when it comes to the health effects. But it's not only those fibers which are legally defined as asbestos which are of concern to us. It's also other natural occurring fibers. It's erionite, which is the sort of really bad thing in this context, creating a lot of mesothelioma, which is a fibrous zeolite. It's wollastonite, attapulgite, sepulite, and fluoradonite, and many others. So what these asbestiform minerals have in common is that they are fibrous, they are flexible, they are durable, they are resistant to heat and corrosion, so that makes them very useful if you disregard the health effects. They have high tensile strength and low electrical conductivity. But if you look at them, they are quite variable in size and shape. Chrysotile, for instance, being very different from actinolite or crocidolite. So how did this whole problem come up? I would like to suggest that it started with a discussion on risks with consumer products which were contaminated with these fibers. There was an investigation performed in the US of talcum and powders, and they found that of 20 products, 10 contained tremolite and anthophyllite, and it was mainly in the fibrous asbestiform type, although there were also some fragments which merely formally fulfilled fiber criteria, but maybe not generally fibers. That they had also up to 14% of the talcum or the powder was asbestiform fibers by weight, so very high. And this has been suggested to be partly responsible for mesothelioma in consumers. I think the next step was the discovery of an endemic occurrence of mesothelioma, which was not related to occupational exposure. And this was reported from various regions in the world. Turkey was very predominant in this. It was the exposure to areonite, but it was also villages with tremolite in the material from the nearby mountains that they traditionally used to whitewash the houses or as stucco. Greece, Cyprus, Corsica. Corsica was another mineral for edenite. And in China, chrysotellite, and this has been reviewed many times, but this is one of the more useful reviews, maybe. So this is very well established that exposure from this whitewash creates exposure which is sufficient to create endemic mesothelioma in the populations, not only those doing the whitewashing, but also those living in those villages where there is contamination in the road dust, etc. You find fiber concentrations also in the sheep. There's also some other examples of environmental exposure to natural fibers from US, tremolite or chrysotile, areonite in North Dakota, Southern Nevada, in Turkey, and in central Mexico. But now we come then to mining. There was then an epi-study published in the late 80s which described that among the vermiculite miners there was an increased risk for lung cancer and lung fibrosis. Vermiculite is a mineral which you mine and produce as a concentrate, and then it's expanded by heating it up, and then you can use it for insulation, and it's used as loose insulation, for instance, in attics. But also for many other purposes. It was also found that there was pleural fibrosis and mesothelioma in this population, and that the neighborhood exposure produced pleural changes and reduced lung function and various symptoms. And this was declared a public health emergency in 2009 by the Environmental Protection Agency. So this is a case where exposure to natural contaminating fibers of another mineral mined has been very well documented. So when does then natural fibers occur together with other minerals which are mined? Well, it's associated with minerals. So if you mine iron, copper, nickel, or gold, you may have natural fibers which occur as a contaminant in those deposits. It's commonly found in veins, often lens-shaped. It can be very small and isolated, and it can, if it's close to the surface, weather and produce harmless secondary minerals, but when you go deeper you will find the real fibers, so that the probability of encountering these minerals in a fibrous form will increase with the depth of a mine. I would just like to show you some measurements from Swedish iron ore mines performed in the 80s. This is fiber counts from stationary measurements, and you see the range from below 0.1 fibers per mil being the current TLV, Sweden for asbestos exposure, but you also see concentrations going up to 8.9 in the crushing and milling place. So it can be a real problem in terms of exposure levels. These studies were followed by a controversy on several points. One controversy was on the fibrous versus non-fibrous form. When you have the same chemistry of a mineral and it occurs both in the fibrous and the non-fibrous form, can you then assume that the non-fibrous form is innocent? I think you can. The main message is yes. Because if you do inhalation studies only of erionite in the fibrous form and in the non-fibrous form, you have a huge attack rate, a frightening attack rate of mesothelioma in the rats in the fibrous form, but you find none from the non-fibrous form. There have been similar experiments, although not that clear, with tremolite in the fibrous and non-fibrous form. So at least for mesothelioma, I think you can say that it's linked to the fibrous form. Then there is the discussion about cleavage fragments versus fibers. The fiber definition says that the length to width aspect ratio should be at least 3:1, and the length at least 5 microns, and the diameter not more than 3 microns. If you subject a mineral to a lot of stress, it can easily split into fragments which will fulfill these criteria. And then the mineralogists say that this is not really a fiber because it doesn't have this tensile strength and flexibility that a fiber has. So then there's the question again, will this sort of cleavage fragment have the same adverse effects as a genuine fiber? And the answer to that is there is no real evidence in one direction or the other. It was recently reviewed by the French Agency for Food, Environmental and Occupational Health and Safety, which said that the data are so sparse that it's better, it's prudent, to take the same precautions as you would with what you are convinced is a true fiber. And then there was this issue of dose response. Would these naturally occurring asbestiform fibers for the same exposure level confer the same risk as the commercially mined asbestos fibers? And experimental data then say that some of these fibers which are naturally occurring as contaminants are more aggressive or have the same risk as those that are mined commercially. For instance, if you compare with amosite, while others appear to give less of an effect. Inflammatory potency was related to fiber surface area for the Libya amphibole, which would then agree well with the fiber paradigms we apply otherwise. So I think that one could sum it up by saying that what we have available for dose response and for risk assessment leaves our existing paradigms for the commercially mined fibers unchallenged, meaning that we have no real evidence saying that those do not apply, so it's better to apply them. It's my conclusion. So then, what about risk management? How do I know that there may be some such exposures, for instance? I think the best way is to get in contact with a good geologist, because this is all linked to the geology, but it's not as simple as asking for one specific type, because it's been described to occur in a lot of settings. And I've listed some of them. There is also a database available, which is called min.org, which lists reported minerals from specific mining sites worldwide. And that's both active mines and closed down mines, and also some mines which are about to open. So what you get from there is the minerals which have been found, but you won't know anything about the levels, of course. But at least you will know if it's known to be there. And for instance, for Sweden, it's listed for 24 mines, active or former. So then, of course, the most important precautionary measure is to avoid exposure. And how do you do that? I think the number one is to involve geological expertise, and they will be able to tell you if there is a risk of contamination, and if it is, where is the contamination? And then you should avoid to mine that part if it's possible. But if you have, and you should avoid, of course, to extract from contaminated areas as far as possible. And if you look at the Australian guidelines, they say you should have a regular surveillance of the ore to make sure that it's not contaminated, and you should have regular checks of the mined ore, your product, for fibrous material. And if there is an area which you suspect may be contaminated, you should control the access to that area until you know, until it's cleared as uncontaminated. So this is all old-fashioned industrial hygiene, in a way. Air monitoring is slightly more tricky than usual, because there's such a lot of other dust in a mine. So when you are monitoring fiber exposure, you want to be able to count the fibers. And it's difficult to count the fibers if there is a lot of dust on top. It's overloaded with dust then. So this means that you may have to change the filter several times during a sampling period in a way that you don't have to do in normal fiber sampling situations. And when we look at dust measurement protocols from the Swedish mines, we can see, the old ones is what I've looked at, you can see that there is often an overload of the filters. This makes counting of the fibers unreliable. It's also important to realize that you cannot rely on bulk data to tell you what your airborne exposure is like. The study on the Libby amphibole, the vermiculite mine, which I mentioned, states that in the raw ore there was 21 to 26% asbestos by weight. That was tremolite and also some other types, not legally defined as asbestos, but very close to tremolite. In the mill feed, it was 3.5 to 6% asbestos, but the airborne dust in the dry mill had 40% asbestos. And I suppose this is because the fibers tend to stay airborne to a higher extent than the normal dust. And in the concentrate shipped for further processing, the concentration was 0.3 to 7%. So still a risk to those workers who were going to handle the concentrate. But I think that the really significant message is that if you compare the ore or mill feed maybe with the airborne dust in the dry mill. So you don't rely on bulk samples, but really take samples from the air. Then minimizing exposure is about dust suppression, enclosure and isolation, of course. and to designate contaminated areas so that you apply all the sort of routines you have in asbestos abatement, basically, so that you don't spread the fibers to other parts of the mine. And personal protective equipment as a precaution is secondary to all these other measures to reduce exposure. And these are the type of measures listed by the Australian authorities to handle this problem. So it's not the wish list of an occupational medicine physician. And guidelines are available from Australia. And there's also supplementary information which I think is very useful. There were also recent guidelines issued from Finland, but unfortunately they are only in Finnish. Google Translator can help, but it's still, of course, not what you can entirely rely on. Maybe a Finnish colleague. So I think that it's these guidelines, you can have, of course, have opinions about details in this, but I think it still provides a coherent structure for how to approach the problem, which makes sense. And then you can always discuss if you want to do details differently, of course. And safe levels then. What is a safe level for exposure to these fibers? Well, one thing is how do we assess the exposure? And one debate which is running is if it should be with optical microscopy or with electron microscopy. And the reason that people are arguing in favor of electron microscopy is that the thin fibers are considered to be the most carcinogenic one. And if the diameter of a fiber is less than 0.25 microns, 0.2 to 0.3, it's not detectable in the light microscope, the optical microscope. And then you would, these are specifically the fibers you would like to monitor. The downside of electron microscopy is that it's more complicated and it's more costly. France now requests transmission electron microscopy for assessment of airborne exposure to asbestos. And the Dutch expert group on hygienic limit values also recommends transmission electron microscopy to catch these thin fibers. And they also say that if you want to compare the levels with transmission electron microscopy and optical microscopy, it's about 50% of that you get with the optical microscope. But this is just averages, because it will vary with the process and the fiber quality. What then is the exposure level which would give an acceptable risk for cancer? Cancer is the critical effect from exposure to asbestos and asbestiform fibers, natural fibers. And usually it's assumed in Europe and in the US that one extra should look at this one. Disregard this one and look at this one. 4 per 100,000 for a full working life is what you consider acceptable. And that, if you assume that you are exposed for a full working life to 0.1 fiber, which is the most common hygienic occupational exposure limit, then the risk is 4 per 1,000 and up. So that's like 100 or more times the acceptable level. And this is, there has been similar assessments made in France and in Germany. In France and in the Netherlands, they have both adopted lower occupational exposure level limits, both 0.01 fiber per mil, that's 1/10 less than the most common one. Moreover, they say this is as assessed by transmission electron microscopy, so that makes it 1/20. And Germany has adopted the same concentration as a preliminary acceptable cancer risk level. So this means that risk-based, we would strive to achieve exposure levels which are much below what is currently permitted in most countries. So to sum up, I'm a bit early. There is emerging knowledge from the 1970s and on occurrence and health effects from exposure to naturally occurring fibers when extracting and using other minerals. There is a controversy on risk assessment, but in my opinion, much of that has passed. And I think the experimental studies are a great help in that. Animal data and epidemiological data indicate that they can cause the same type of diseases as the commercially mined asbestos. They probably have a varying potency per unit of exposure, but this is not very well established. So the best evidence we have is to base our assessment on what we know of the dose response for the commercially mined asbestos. In my opinion, national guidelines should be developed for handling naturally occurring fibers in mining situations. And I think that these should also include cleavage fragments, which means that you implement the WHO fiber definition also in these situations, and you don't make any type of amendments. Some countries tend to permit higher exposure levels to asbestos fibers in mining than in other situations. And I don't think there is any scientific basis for that. I don't think there is any medical basis or other basis to accept the higher risk for mining, in my opinion, is a double standard. And I think we should avoid that. So that's what I had. Thank you.